Hello everyone, this is Monish Mitra, and today we are going to look at how we can make the computer play a snake game using reinforcement learning. Firstly, let us look at how a normal snake game is played and let us understand how the scoring is done. So, as you can see, there is a food in the random spaces, and as the snake collects the food, it keeps on gaining score, and at last, when it touches either the boundaries or when it touches itself, the game is over. That is the end of the game. So that is how the snake game works. This is a general snake game. So similarly, our goal is to train an agent to play the snake game and obtain a good high score. So let us run this agent that plays the game, snake game, and see how it is in its initial phase. So as we can see, uh, the initially it doesn't get much score. The highest score till now is just one. So while this keeps on training itself for a few iterations, let us look at a little theory about how this model works. So let us look at the snake game using reinforcement learning. So initially, what is reinforcement learning? Reinforcement learning is a type of machine learning algorithm where an agent learns to behave in an environment in a random way without any predefined suggestions or any inputs. So the agent is given rewards if the action it takes leads to a desired outcome, and it is also given a penalty if the actions that it takes lead to an undesired outcome. So from this over time, the agent learns to take actions and maximize its rewards. Reinforcement learning is used in many fields such as robotics, games, finance, and healthcare. Learning can be a powerful tool, but is also challenging to use. Next, what is deep Q learning? Deep Q learning is a reinforcement learning algorithm that uses a neural network to approximate the Q function, where Q is the optimal action selection in the neural network. The deep Q learning is able to learn the Q function even when there are a huge amount of states and actions given. This is an off-policy algorithm, which means that it can learn from the experience even when the agent is not following an optimal path. Deep Q learning has been used to solve many problems, many reinforcement learning problems, including the Atari game, controlling the robots, and trading stocks. In our code, we have used two libraries, that is the PyTorch and Pygame. Uh, PyTorch is a deep learning framework which is based on the Torch library. It has two high-level features, that is the tensor computing and the deep neural network. And PyTorch is a popular choice for deep learning developers and in research areas. Next comes Pygame. Pygame is a Python library for creating a 2D games. It has a simple API for creating and managing sprites, which are the main agents in the games. And Pygame also has a built-in networking library. So let us look at the organization of the code that we have done. So it has three major classes, namely agent, game, and model. So the agent is basically the agent that plays the game automatically. It has game and model subsets in it, and it keeps on training itself from the given states, actions, rewards, and it finds out the new states and remembers how it played the game in the past and how should it play in the future to attain maximum score. So this is how the model gets trained in the agent class. Then comes the game. So game is basically the environment in which the agent is playing the game. It has a play step function in it, which basically takes the input from the agent and allows the snake to move, and it records the game rewards, the game over and score. And finally, model, we have the model class, which is the linear QNet, that is a neural network that updates the Q value. So this basically, it is used to predict the model's next state and action. Coming to the reward functions, if the snake eats some food, we give it a score of plus 10. If it's a game over, that is, if it touches the boundary or touches itself, then it is given a penalty of -10, or in any other case, it is given a score of 0. Next, the snake has three actions. It is either go straight, turn right, or turn to the left. So these three actions are given in the following arrays. And then it has the given agent has 11 states. It either has a danger to the straight, right, or left. It can either go up, right, down, or to the left, and it also has food to the top, bottom, left, or right. So these are the 11 states that are possible in this for the snake. Next, this is the feed-forward neural network for the updation of the Q value. So initially there are 11 inputs. This is 11 input layers, and then it has a hidden layer network, and then we are having three outputs. So we are having 11 input layers. This is because there are a total of 11 states. So we give each state as an input. Then in the hidden layer, the processing is done. The feature processing and everything is done. And finally, we get three output. That is which action to take. It is either to move to the left, right, or to the straight. So it has the array has three values, and hence we are having three output nodes. Next, we are having the deep Q learning algorithm. The deep Q algorithm is as follows. For initially, we'll have a Q value, an initial Q value, which is the quality of the action. Then we choose an action that is either the model predicts the new state and then it takes the action, or else it does a random move. So after performing the action, the reward is measured and the Q value is updated. So this is how the model keeps on training and the Q value is updated. And this is repeated on a loop until a good Q value is attained. Next, this Q value is updated based on the Bellman's equation. So as we can see, this is the formula for the Bellman equation. And then the Q value is updated as follows. Initial Q is the model's predicted state, and the q value is the reward plus gamma into the maximum of the q in the next state. So this is the new q value. And coming to the loss function, we are using the mean squared error for the loss function in this method. So the loss that we get is equal to the new q value minus the old one whole squared. So this is the basic theory behind how the reinforcement learning is used to play the snake game. Now let us look at how the different parts of code works for the training of the agent. So initially we are having the game.py. In this we import the pygame library and make the environment for the game. So we give the class for the directions of the snake. Then we set up the color for the background and the snake color. Then in a snake game AI class, we are having an initializer function and a reset function to reset the game when the game is over. Then we have place food function, which basically places food in random positions once it's eaten. Then the play step function has six functions in it. The first one is to collect the user's input. The second one is to move according to the input given. Then the third one is to check if game is over or not. The fourth one, if the game is not over, it places food in a new place in the new space. And then the fifth one is to update the UI and keep on updating the clock. And last one is to return a game over if it's over and give the final score. So this function here is used to see if there's a collision of the snake with the boundaries or itself. So that is what is given in this code. Next, we define the UI for the game space. So this is how the UI looks like. Next, we define the movement of the snake. So as you have seen earlier, if it's a if we have to move straight, then we give an array of 100. If it has to move right, we give it as 010. If it has to move left, we give it as 001. So that is what is there in this move. So this is the basic structure of the game.py. Then coming to the next one, it is helper.py. This code basically just gives us a plot of how the game is being played. That is how much score you are attaining per game, and the average score is calculated. We'll see this plot in the upcoming time. So next is the model. So model is basically the queue network model that we are making to update the queue value and to predict the new state for the reinforcement learning agent. So in this queue trainer, we initially initialize all the values, and then we define the training step to train the queue model to keep on learning the new queue value. In this, the queue value is predicted with the current state, and then it is updated as you have seen the new queue value earlier. So it keeps on updating with that value as you can see here. And finally, it gives us an optimal movement for the next state. So this is basically the complete overview of the model.py. Then we have the agent.py. So agent.py is the one who plays the snake game on its own using reinforcement learning. So we call the class agent and initialize all the values that we require. Then the get state function gives the agent about where its position is right now and what it has to do in the further place. So a few get state values that it can get is if there's danger around it, or it has to move in a particular direction, or if there is any food present all around it. So as we have seen 11 states, this is the function to get the exact state in which it is in. Next, we have the remember function. So in this, we are having two functions, that is the train long memory and train short memory. So the train short memory is basically to uh, for the snake to take the next step. That is just if it has to move straight, right, or to the left. So that is done using the training short memory, and the long memory is used to keep on updating the queue value. That is, it keeps on learning. So the learning is saved in the training long memory, and it is used for the improvement of the game's performance, snake's performance. So next we are having the get action. So get action basically it gives us the random moves. That is the total trade of exploration divided by the total exploitation. This is the value for the random move. So this function is calculated in the get action. Finally, we define the training method here. So all the scores is calculated and the previous long-term and short-term memory that it uses here to play the game and get a new high score every time it plays. So this is the basic code structure that we have seen. So finally, let us look at how the game is played and how it's going on. So as you can see here, initially it had a high score of 0 to 1, but now as we can see, the training score has gone up to 70, so which is a very good score in such situation. And as you can see, it keeps on learning. All the time it keeps on playing. So as you can see here, the orange line depicts the average score of the snake till all the games played till now. So till now, the snake has played around more than 250 games, and its average score currently is 22.3. So initially, we were having an average score of around 1, 2, or maximum 3. So as the agent kept on learning from its previous experiences, its high score and also the average score keeps on increasing in a linear manner, as you can see in the orange line. So This is how we can train an agent to play the snake game and teach it to perform better using our reinforcement learning and updating the Q values. Thank you.